Hi everyone, my name is John Dickinson and this is the CSCIE 90 final project extended presentation, creating a blockchain network using AWS. If you already watched the 5-minute video, you probably saw the Node.js application in working there. So we're going to walk through everything here all the way up to the deploying the Node.js application. We're going to implement a smaller blockchain on the way there. And yeah, let's get started. So, first thing that I want to talk about is just quickly to kind of get some stuff out of the way. So this is a cost example of the blockchain network using AWS Managed Blockchain. Just kind of in a nutshell here, the total test network hourly cost is about 70 or 68 cents an hour. That's about $16.22 a day. Monthly, $486. Yearly, almost $6,000. So yeah, obviously that adds up very quickly. I put this here because you definitely do not want to just leave this service running. So you don't want to, deploy a blockchain, testing it, and then like come back 3 days later or a month later. Because if you do, you're going to have a serious issue. Maybe not a serious issue, but you're definitely going to be spending money on, a network that's literally just sitting there doing nothing. Now, if you want to deploy it and you have other stuff going on and you want to pay the money, then go for it. But this is an expensive service, so I wanted to make sure that I let everybody know that before they start going through this. So what we're going to do first here is we're going to use Cloud9 to set up an IDE. We're going to provision an EC2 instance here. So this is how we're going to go and just set this up here. We're going to name this thing. We'll name this CSCIE E90 project. The description is optional. I'm not going to use that. Create a new instance. It's recommended to go with a T3 medium for this one. Just because there could be a lot of transactions on your blockchain. So you might need the extra gigs, the extra RAM to be able to process everything. And just to kind of make sure everything's going to work, we just go with a little bit of a larger instance here, so that things aren't getting bogged down. Though it'll probably be fine, but let's just for simplicity's sake. So we check that all out. We're going to Amazon Linux. We make sure everything else is good. They populate the role for you. Go to the next step. Little reminder of best practices. So we create. This could take a few seconds to provision, but I go with Cloud9 on this simply because it will fire up the instance quickly. You can use sort of like tab shell instances, which is nice. Getting into this later, not having to kind of click around on your computer trying to figure out where your terminal is. So I'm happy using this. If you want to just use the regular version, or you want to just use an EC2 instance and SSH into it, then go ahead by all means. You're more than welcome to do that. So some services that we'll use to complete this, mainly Amazon Managed Blockchain, which will provision a lot of this stuff for us. We'll have to deal with the VPC. We're launching some EC2 instances. We've already got Cloud9 going. We're going to need S3 to download a certificate file. CloudFormation will launch a few stacks for us to provision some resources so that we don't have to do it and configure it ourselves. You can definitely configure it yourselves. However, I did it that way, and it is prone to error. This is a nice kind of quick way to do it with scripts that Amazon has provided. So, and we're going to use Docker as well. Docker will be used on the peer pretty extensively to query the chain code, and basically all interactions with the chain code will be used through Docker. So let's see where we're at. Okay, we got something up and running. Great. I like to get rid of that. Just a welcome screen. Give me a little more space here. So first thing we're gonna do is we need to clone the GitHub repository that has all these AWS samples in it for this blockchain that we're going to make. So AWS has created a ton of samples. Basically, you download the sample information in, and then you can walk through the steps of setting this whole thing up. So the first thing you're going to do is change directory, the right directory, clone this thing, not that. And this is going to clone all the necessary documents and all the necessary source code that we're going to need, a few scripts to get this thing set up. This thing I'm referencing here is my project write-up, so it's not exactly finished yet, but we use it for reference. So we might be altering some lines of code here. So like that one. But oh, we're missing a dash, of course. One dash. That's what I figured it was, but just might as well check. So what did we have? What did I have wrong there? Oh, I must have had an extra space. Okay. So now this instance does not have, or we're just going to upgrade to, we're going to make sure that we're on the latest version of the AWS CLI. So that's what we've done here. So moving on to the next step. What we're going to do now is we're going to provision the blockchain. And we're going to do this by running this particular script here that AWS has provided. What it's going to do is it's going to set up a couple of environment variables, and then it's going to go out and it's going to create a stack that's going to create the the blockchain network with a bunch of various different parameters that we have selected. So it'll have a certain username, it'll have a certain password, it'll have a certain member name. Basically, what it's going to do is it's going to sort of standardize all the different variables or all the different parameters here, so that we don't have to deal with going into scripts and changing out member IDs, making sure we have the right member ID, making sure we have the right network ID. This is going to handle all that by basically setting up environment variables that have all this stuff, and then being able to call those environment variables through different scripts that we have written. So this takes a while for this to provision. This is probably going to take about 15 minutes. So we'll just take a break for a second here and then come back to it once this has been provisioned. Okay, so our stack is finally ready to go, which means that our blockchain has finally been created. And we can tell that because we look over here, nonprofit A and B, create complete. December 6th, that's today's date, 8 o'clock. So now, well, 9 o'clock. So you can go over here And there's our available network. This is our available blockchain network that we're going to be working with. So now that our blockchain network is up and ready to go, and we've got some members, we've got a member, and we've got a peer node associated with that member. So what we're going to do now is we need to create the VPC that the Fabric client node will live in. So the Fabric client node basically is going to be the thing that you use to interact with your peer. This error is going to throw an error here, which is fine because it's telling you that it did not find a key pair named NGO dash key pair, which is what you want because otherwise it would have overwritten the key pair, or in this instance it would just error out and tell you that it's not going to overwrite it. But anyway, so we're provisioning this VPC where the Fabric client node is going to live, and the Fabric client node is going to be the thing that we are going to basically we're going to execute we're going to administer the network with the Fabric client node, and we're going to execute commands on the Fabric client node that are actually going to be we're going to put the commands in on the Fabric client node, but they're actually going to be executed on the peer, or it's going to tell the peer what to do in terms of installing the chain code, invoking the chain code, instantiating the chain code. So it's a very important part where we need this VPC so that we can create a VPC endpoint so that the Fabric client node will be able to speak with the network. That's what's being done here. And luckily, Amazon has taken the time to write a shell script for us that's going to handle this. Okay, so our VPC has been provisioned, and we can see that here, NGO Fabric client node, create complete. You can actually see the exact things if you drill down on it. See all the resources that it created. Security groups, subnets, VPC gateway. So, this is a huge help that you don't have to sit here and go through and do each one of these things individually, which is great. So that takes that takes care of a lot of the legwork. So next, what we need to do now is we need to prepare the Fabric client node, which basically means we need to install. We need to source some environment variables, and we need to get the certificate, download the latest managed blockchain PEM file, and then we need to enroll this particular Fabric client with the certificate authority. Basically, get a certificate from the certificate authority so that it'll permission it so that to interact with the blockchain network. So, a bunch of stuff we need to do here. So, first thing we need to do, our Fabric client node has been provisioned, so we need to get we need to connect to it. That'll be the Managed Blockchain Workshop EC2 client. We're going to connect. That key pair was created in one of the stacks. It's just sitting on. It's sitting on the your Cloud9 instance right now. So let's change this directory. For whatever reason, this shows up as root. Make sure you don't log in as root. It won't let you. EC2-user. Yes. Starting the command line interface, and we're in. So this stuff will all, when you tear the network down, all this stuff will go will go away. The key pair will be wiped out. All of these instances will be shut down. So you'll be able to get rid of all this stuff. So next we need to clone this repo, get all the various different information that we need so that we can put it on the peer. We need to be able to install the chain code onto the peer. A bunch of stuff that needs to be done. Right here we're going to run a script that's going to source all the environment variables again. Amongst installing a bunch of different stuff. Python, a few other things. So there are our environment variables, and this stuff was all provisioned by the stack. So this stuff would be, once you tear this network down, this stuff will all be gone. But you need to have this stuff in here. It's much easier to just have this as these different environment variables, because then you can just kind of just go, echo admin user, there it is, admin. So you don't have to go back and just keep changing all this stuff in the various different files, because the various different files are just going to use the environment variable. So, it'll just use that in the scripts, which will make things much easier. You won't be in there just manually changing things out, making all kinds of errors, and wondering why it's not working. We can run this just to make sure that it went through, even though we already know that it did. So there you go. We have a peer service endpoint. Let's get the latest copy of the managed blockchain PEM file. Hit that from an S3 bucket. Hit the S3 bucket to get that. Now we're going to enroll. This is very important. You're going to enroll this with the. We're going to enroll this as the administrator of this network. Well, we're gonna enroll it as a Fabric client admin, which will allow it to give commands to the peer and tell the peer what to do, and the peer will interact with the orderer, which will make the blocks. So this we just need to get the certificate over into the right location for later. Now what we're going to do is create a channel so that the Fabric client can speak with the peer. So the first two lines of the first two commands I just put in there and ran. That's the configuration that are going to tell this Docker command where to go. That's the configuration that we just set up. Now we're going to actually generate the channel, but we needed to set up the configuration to execute this Docker command with the correct configuration in it. So right here, info writing new channel TX, we know that it was a success. So the channel has been set up. You could run this and make sure the channel's there, but it will be there. Now we're going to run this. Oh, sorry. That was so the channel configuration has been generated. Right, so it makes it now that once we create the Fabric channel, which we're going to right now, it's going to that block that we created by running these three commands. It's going to make that the first block on the chain, also known as the Genesis block. So now we're going to run this, and this creates the channel. That's good. This is good. This means that this has been successful. And just to make sure, there it is. We can see that the block has been created. The channel has been created with that block. Just run this one too. Just make sure and just check. So that's there as well. So now we need to, now that we have this channel set up, we need to join the peer to the channel. So that was successful. Successfully submitted proposal. Now the peer has joined. So now they can communicate. So what are we going to do? Now we're going to install chain code on the peer. So the client fabric node is installing this chain code on the peer now. So the peer will be able to, so that when we tell the peer to run commands, it will be able, there will be code for there that it can, so that it can run these commands. Just a bunch of various different chain code functions that will be in this chain code that the peer will now be able to run. You know, some of those functions being, you know, instantiate, which is this one right here. Basically, what we're doing is initializing. Stop it. We're initializing the ledger with these values. I'd like to change this. Sort of simulate like a bank transaction. Set bank A up with 100,000. Set bank B up with 200,000. So that's going to initiate the chain. It's going to initiate the ledger. A block will be created. This can take like 30 seconds, so it takes a little bit of time, but nothing crazy. So while we're waiting for that, we'll run a query, and we're going to run a query for bank A, and we should see 100,000. So we need to change this to bank A. There you go, 100,000. So the next thing we're going to do is we're going to transfer money from bank A. Let's transfer money from bank B to bank A because they have more money. So we're going to change this to bank B. We're going to change this to bank A. And we're going to send them, 50,000. Not that much. It says it's good. So what do? We query this chain code. No, Dorson's fair query. Oh, right, because I didn't change this to bank A. 150,000 bank A has now. And what does bank B have? Bank B has 150,000 now. So we moved $50,000 from bank B to bank A. And now they both have the same amount of money. But you can see how this could be used, how this could be very powerful. There's no centralized database here. This is just information walking across the blockchain and then coming back and being stored locally on this peer and then being queried. You know, this is very, very interesting stuff. You know, it could definitely increase your level of security, and you don't have to worry about someone hacking in and changing your database records. Not to mention that you can have a ton of different people on this network all looking at this information at the exact same time and not having to worry about who owns the information. So that makes it interesting. And this is kind of just a, you can see this is from the AWS samples GitHub repository. And it's kind of just talking about what's occurring here. Sending transaction endorsing peers for endorsement, the packaging the endorsement from the peers, sending the package endorsements to the ordering service for ordering. Ordering service groups the transactions into blocks and then sends the blocks to all peer nodes for validating and committing to the ledger. So that's the full chain code process, or that's the not chain code. That's the full blockchain process as the chain code is being run. So the chain code is just there to provide these functions to the peer, and then this is how the information flows. So that's the end of what I have written up, but I've showed the Node.js application in my previous presentation. So more or less, I'll just fly through getting this installed so you guys can see how it was done. If you're interested, and it probably won't take too much time explaining stuff. Possibly I'll add this to my write-up, and my write-up's already very long. Even though this is only a few things, there's a lot to explain here, and I really haven't explained much of it in detail. Strictly for time purposes of this presentation, but I can more or less just fly through this code and show you how this is going to work. So what we're going to do, probably don't need to do this because we didn't exit because I didn't exit the SSH session. Probably don't need to do this, but I'm going to source this stuff anyway. Because all the source is doing is updating these variables. So if anything changed, now we have all the fresh variables and we know everything in our environment's good. So to me, might as well just do it. You can run into issues with that if you're doing that like crazy and at the wrong times, and then you're starting getting variables that you shouldn't be having in there. That can happen, especially if you're playing around with things. So what we're doing now is we're copying some new chain code in because we're going to be doing the nonprofit organization application, and this requires a different chain code. The different chain code just has different functions, and you can kind of build it out whatever way you want to. If you go on the GitHub repo, for this, the AWS samples GitHub repo, you can inspect the code and you can figure out what's going on. Which I definitely recommend doing that. You can take a look and see all the different functions they have, how the functions have been written. You can change stuff if you wanted to and deploy it on your own and see how it works. So that comes back as nothing, which is good because we haven't put any donors in yet. Now we're going to invoke a transaction on our peer for this chain code, this new chain code that we just installed. So what have we done? Okay, chain code invokes successful. We created this donor named Edge. Edge is a guy who works at Amazon who did I think his name is Michael Edge. He did a demo of this on YouTube. You can look it up. Great demo. So this is his information that's showing up on here. It's also obviously in the sample repo. So, and then this is another one, donor with this name there. I'm not really sure how to say that, so I'm not even going to bother. I'm not going to bother butchering this guy's name. But now that we did that, if we go in here and we can set up this chain code, we can query it and we can see that now we have this donor here, username is this, and we have the other donor username of Edge. So we have users in this blockchain. You could also run this, which will query. Why not, right? You can run this, which will query a specific donor. So these these things here, this chain code query that we're running, these arguments, this is what's in the chain code. There's an argument for there's a method called query donor in there, and then it needs a specific set of arguments to be able to query it. You need to go inspect the chain code and figure out, so and look through the chain code and see what kind of arguments they have or what kind of methods they have, so that you can call them and make sure that you look at the way make sure that you look at the way that the syntax is for this particular command, because there's obviously a ton of stuff going on in here in this command. There's like a bunch of different things you could easily mess up, so you need to inspect that and make sure you have that right, because if it's off by a little bit, it's one character, it's not going to work. So we're still SSHing to the Fabric client node. We have all this. Probably, for safety's sake, let's just source our stuff here. So we're going to install Node.js. We need that to run the Node.js application. Without that, we are not going to be running any Node.js applications. So we're going to install that. Long NVM. Okay, we're going to use Node now. Okay, great. So, for whatever reason, Amazon Linux does not have G++. It's getting it now. Dependencies, these are just the stuff that you have to put in here. Dependencies that your Node.js application needs, so you have to put them in, because it won't have it otherwise. So this is for the API. The API needs a connection profile to the Fabric network, and this is how it's going to get its connection profile. We're going to run these codes to set up these commands to set up a connection profile, so that it can interact with Fabric network. Sort of like how we had to create a VPC endpoint so that we could interact with the so that our Fabric client node can interact with the blockchain. There's just a bunch of various different stuff you have to set up. Getting that, and this is just showing the connection profile that we have. Basically, what you would want to do is you want to make sure that this stuff is accurate. You can check that. You can go back in Amazon Managed Blockchain and look at your various different. So, for example, we already know that this is good. We know that. So, CA name, that's going to be the member name. Yep, member ID right there. From doing this installation about 7,000 times in the past 2 weeks, I can just look at this stuff and tell when it's right and when it's not right. So now we're going to run the app. So now the Node.js app is running. Right now this isn't really going to tell us much. It won't really mean much to us, but once we get later on, I'll show you what this is doing. Right now the app's just running. So now we need a new window of just Cloud9. We need to... No. So we need another window where we're going to SSH into our instance again. Right, and we're going to enroll some. We are going to enroll some users. And as always, change this. User. Yep, we're in. Wonderful. Now this request is going to register a user in for the application. Michael, his name, org1. That's good. Enrolled successfully. Great. Now, hopefully this works, which I'm sure it will because we've provisioned this from scratch. But I did not. I spent a lot of time. Yeah, okay, it came back. This is how this transaction ID means it's good. I spent a lot of time because I was tearing stuff down constantly, trying not to pay crazy bills, leaving this network up overnight. So you're working on it for 3 or 4 hours and you're tearing stuff down. And this is really not designed this particular way. This is this particular way that these commands are laid out. It's not designed to have stuff torn down and then put back in and reused. You really need to do this stuff like you need to do this whole thing one shot more or less and get the whole thing to work. Now you can tear it down and you can reuse the things and you can get it to work. But it's way more difficult, and as opposed to just running all the commands again and starting from scratch. But that's only if you had to tear down the. That's pretty much only if you had to tear down the blockchain network. Because if you didn't have to tear it down, if you are keeping it running, then it's fine. But so we can see here that was our query that I just queried all donors. They're all there. Brandel, Edge 2. They're all there. Now we're going to run this script. This script loads a ton of test data into here. It basically instantiates a bunch of it just basically creates a bunch of non-profit organizations, and it gives them account balances, so that and you can see later on it gives them that right there is a description of what this particular nonprofit does. So that's what we're doing here. Now we're creating some transactions, which is giving them money. Now we're creating, or actually those are creating ratings. Now we're creating donors. These are random donors. Jane and Louisa have been added. Now we're creating donations, which is setting up balances for these nonprofit entities. Now these spends. This is interesting. This is what you'll see is basically the application is going to be randomly spending money. That's what's going to be happening here, and you'll see. It'll make sense when we take a look. So this all needs to be done on Cloud 9. These next steps. These need to be done on your Cloud 9 instance. Definitely not in your Fabric client node. So we should have this already because we already cloned that in part 1. So we should have that. So what we're going to do is we're going to install Node.js. We're installing this on the Cloud 9 on the Cloud 9 instance because the Fabric client node already has Node.js. Now we're going to take this, we're going to run this, NVM, great. Same step here, we need our dependencies again. This is a different computer, different instance. This is important. This is the load balancer. There was a load balancer that was provisioned in one of the CloudFormation stacks. So we're just getting the DNS endpoint so that we can point this Node.js application to the REST API. So we can use the load balancer. All right. Now this is where it's going to get interesting. Well, not yet, but it'll get somewhat interesting. Assuming this doesn't blow up. There we go. That's what we want to see. Angular Live Development Server is listening. It's kicking off. So we're going to preview the running application. So we're going to pop this out because it's easier to work with. So what we need to do here actually is we need to use HTTP because I forget the exact reason why. Well, we can actually look it up right now. I believe it was just not written in HTTPS, or you know, I don't know a ton about HTTPS versus HTTP. Maybe there's something they had to include that wasn't included, or maybe it's just not. And I could also stop guessing and read why. It was in here somewhere. Must remove HTTPS. The application does not use TLS SSL, and most modern browsers will not allow you to call an HTTPS endpoint when the underlying application makes HTTP calls. Right. So the underlying application makes HTTP calls, not HTTPS. So we need to use HTTP, which is more or less what I thought in the beginning. But now we know. So we're going to sign up. Test this. This can literally be anything. Test@test.com. Why not? We're going to sign up. And we're going to make a username. Oh, wait, we already did that. We're going to log in. Test. And we're in. So this was the application I showed earlier in the 5-minute presentation. I'll just give a brief overview again. We've got right here on the left, these are the nonprofit organizations that we set up. We instantiated them with a balance of whatever this balance was that we gave them. This is probably more or less just the same. What we can do is we can donate. I didn't show this before, but we can do this. So we can go to Books Now Fund. We can donate them fake money of $500. Let's make it $5,000. It's fake. Feeling generous here. So we donate that. That's going to run, and now their balance should be $5,100, which it is. So that's good. We know that's working. So these blocks up here, what's happening here, with the exception of probably this one, which is probably where my donation just went. These are the Node.js application. If you look in the code, it's calling a function called createSpend, and it's just creating it's grabbing a random nonprofit and simulating them spending money. So that's what's going on in these blocks. And you can tell that by going back here, close this, and we can wait for a second and one of these will pop up right now over here. So there it is. Okay, so function create spend. Okay, great. So what's getting spent here? That's just for the description. It's just like a tongue twister. Peter Piper's poultry portion for pets. We're spending $69, and who's spending $69? You have to look this up because it's in here somewhere. It'd be nice if this was parsed out. It's not. Well, that was my donation. Okay, back to here. Oh, there it is. It was 11003. So the registration number 11003 spent $47. This was a different one. Create spend 11003. Let's go back over to here. This is the number, registration number. Animal Troops 11003. They spent $47 or whatever it was, and that's the utilized fund. Is the total amount of money that they've been spending, and it'll just randomly go through and spend. And I'd have to look at the code. I believe the code is a random amount of money. I have to go back and look. I'm pretty sure it's just a random function with parameters. But it is cool. There's stuff in there where the chain code will throw errors if you try to spend money you don't have. They won't allow a transaction like that to go through, which is cool because that's how you can kind of see how you can customize this stuff and how you would, if you were setting up your own chain code, what kind of functions would you allow? Would you allow, let's say it was bank transfers. You wouldn't allow somebody to withdraw money from someone else's account. You'd have to have some kind of mechanism in your chain code that would stop that from happening. You'd have to make sure that whatever member ID you had, or whatever peer node ID you had privilege to this account that you're trying to take money from, and you could map the accounts to a peer ID. But you actually probably wouldn't want to do that because the whole point of this is that you can kind of have a degree of anonymity between your account and your peer ID. But you could you could do it another way. You could just simply say, or you can encrypt it and just simply say that this is, this account has, this. Well, actually, I'm not 100% sure how you would do it without mapping it in some way, but I'm sure that you could, because you wouldn't necessarily know which peer belongs to who. So that's another way that it could be done. Or it could be even simpler. You don't even have to look at it that way. You could just map the peer. Yeah, you would have to map the peer in the beginning to the account that the peer has set itself up with, and then that's the only person. That's the only account that it can deposit or withdraw money from. It can't withdraw money from any other accounts. So you can set your code up that way. You can kind of pick. Well, you'd have to pick whatever way you would like to do it. But there's a ton of various different applications here of how this could work. And you can play around with it and kind of figure out how it works and how you could implement something like this, or a solution that you think that you could create for someone who could use this type of network that doesn't have a centralized source of information. So that's about it. That's pretty much all I wanted to cover here. I hope that you learned something from this, or I hope that you enjoyed it. And any comments would be appreciated if I've described something the wrong way. But hopefully you like this, and I hope you have a great day.